Hello, scientist. So this is your work from February the 11th. And I just want to give you a little video on how to work through a couple of these, especially for those of you working and reviewing at home. So here we go. So I want to go first over the Lewis dot structure showing ionic bonding. And remember, ionic bonding is when you have a metal and a non-metal transferring electrons, because your metals want to give away all of the valence electrons, but your non-metals want to have 8 of them around its Lewis dot structure. So you can see here I have, not only do I have my worksheet with me, but I also have periodic table. Both of these are fabulous tools to always keep on hand. Okay, so let's work on barium oxide. So looking at the periodic table, I want to find barium, and that is Ba. And the more and more that you use the periodic table, the faster it is to find them. I noticed that barium is in family or group 2. So that Roman numeral tells me that I'm going to have 2 valence electrons. And also that this will have a positive 2 charge. Okay, so let's go ahead and write my Lewis dot structure for barium. And now let's get ready for oxygen. So oxygen is way over here. Oxygen is in group 16. That tells me that it has 6 valence electrons, but its charge is going to be 3, 4, 3, 2. It's going to have a 2 negative charge, or a negative 2 charge. So let's do the 6 Lewis dots all around it for the valence electrons. And what this tells me is that barium will have 2 valence electrons to get rid of, but oxygen can only take 2, which is great because that means that one can go over here and the other valence electron can go over here. So I'll only need 1 barium and 1 oxygen to make this formula work. So we have 1 barium and we have 1 oxygen. And the other thing you do here, you can also do the crisscross. As we know, this is Ba. And for barium, it's in group 2, so it has a positive 2 charge. And then we have oxygen, and now it has all 8 valence electrons because it took 2 away from barium. And now it's going to have a negative 2 charge. And then if you were to crisscross these, well, these are the same numbers but opposite charges, so 2 take away 2 is 0, so they will just cancel each other out for charges. So this ionic bond is quite neutral. Okay, let me show you calcium chloride next. Calcium is Ca, and that is also in group or family 2, so we're going to use that same information. 2 valence electrons because it is in group 2. And then we have chlorine, which is here in group 17. That tells me it has 7 valence electrons and it has a negative 1 charge. One, 2, 3, 4, 5, 6, 7. Okay, and now what it's telling me is that chlorine can take only 1 valence electron, but calcium is like, I want to get rid of 2. So this 1 chlorine that's already over here is like, okay, go ahead and give me 1, and my shell is now full. It is very happy. But calcium is still not so happy. It still wants to get rid of that last valence electron. So what do? Well, we just reach up and we grab ourselves another chlorine. So let's just squeeze it in down here. And now this other electron can go down here to this calcium. So now we see how many calciums do we have? We ended up with just 1. And how many chlorines do we have? We now have 2 chlorines, calcium chloride. All right. Let me see if I want to do aluminum oxide with y'all or not. Yes, let's do aluminum oxide. Okay, so sorry for the interruption. Here we go. Okay, so here we go. Aluminum. If I look at my periodic table, I notice that aluminum is over here in group 13. So that tells me it's going to have 3 valence electrons, and that means it's going to have a positive 3 or 3 positive charge. Okay, so let's go ahead and get aluminum ready. Actually, I want to show you how to do it crisscross. So let's just jump into crisscross with this one. So first we're going to have our bracket here, and then we have, where'd it go? Aluminum. And then over here we're going to have oxygen. And we know from our earlier work that oxygen is going to have a -2 charge. Okay. Okay, so this has a 3 positive because it's in group 13, and this has a 2 negative because it is in group 16. Alright, here we go. We want to crisscross. So the first thing I want to do is let's go ahead and just copy the symbols down here. Now your 3 is going to cross over to oxygen, and your 2 is going to cross over to aluminum. So what this tells us is we need 2 aluminums and we need 3 oxygens for this to be a very happy and very stable compound. Okay, so now let's do